All right, so here we have a function. It's a parabola with a vertex at 1, 9, and the zeros at -2 and 4. And then we have a second function, and this one's not graphed, but I would strongly recommend you graph it. So we're going to start at +2, which is right here, and we're going to go -3 and then 1. So negative just means it's going to slant left. So you can still go up 3, 1, 2, 3, and go to the left 1. So it's going to intercept here at at +5. And then come down 1, 2, 3, and go to the right 1. And 1, 2, 3, into the right 1. And it'll just go off the screen. And there it is. Okay. So there's our function in all of its glory. So then which statements are true? Select all that apply. So f of -2, so I'm going to change colors here. F of -2, the f function, is greater than g of -2. So that would be this spot. Well, we know that that's not true because f of -2 is down the bottom here, and that's less than. So that is not a true statement. How about f of -1? So f of -1, here's the f function, and here's where it hits at -1. And g of -1 also is the exact same spot. So they're not less than, they're equal to. So that is also not a true statement. How about when f of 0? When x is 0, f of 0 is at 8, and g of 0 is at +2. So we're saying f of 0 is greater than g of 0. Well, that is true. The f function's higher at 0. All right, how about f of 1 is less than g of 1? Well, when f is at 1, it's up here, and g of 1 is down here. So that is not true because g of 1 is actually, no, f of 1 is, yeah, g of 1 is less, not f of 1. So that is not true. And then f of 2, the function f, when x is 2, is right here, is greater than g of 2. And g of 2 is down the bottom here. So that is also true. So your answers should be C and E. All right, number 11. This is a big one. And I can only fit 10 minutes worth of video in for YouTube to take it. So I'm going to have to travel through this one, but here we go. So Leah would like to earn at least $120 a month. She babysits for $5 per hour, and at the ice cream shop, she's got $8 per hour. So I've always said, when doing systems, and this is what I was trying to explain in class, keep the money together. So the babysitting hours, she earns $8 per X, are going to be different than her, sorry, it's $5 per X, are going to be different than her ice cream hours. And so we're going to make that a different variable. And this has got to be at least, so greater than or equal to, $120. So keep the money, and the money together in one inequality. Okay? Now, the total number of hours that she babysits plus the total number of hours that she works at the ice cream shop has got to be no more than 20 hours. That means whatever hours she works at babysitting plus whatever hours she works at the ice cream shop has got to be less than or equal to 20. So now we're going to take these two inequalities and we're going to graph them. There's not a way to solve this algebraically. Because they're inequalities, you need to graph them. So we're going to take, let's just start with the x plus y in standard form and put this into slope-intercept form because it's quick and easy. You subtract x from both sides, and you get y is less than or equal to 20 minus x. So our y-intercept is 20, and our slope is 1. Well, all of them have a y-intercept of 20 and a slope of 1. So that didn't help us yet. Excuse me. And so let's take a look at the other equation we have 5x, and again, this is in standard form, plus 8y is greater than or equal to 120. And so we need to put this into slope-intercept form. So we're going to subtract 5x from both sides. And we now have 8y is greater than or equal to 120 minus 5x. Divide both sides by 8, all terms. Y is now greater than or equal to 15 minus 5/8 x. So let's find the equation or the inequality that's graphed that has a y-intercept of 15. Well, guess what? A and B do not. They have 20 and something higher than 20, so those do not work for us. So now we're down to C or D, and the way we can tell is to put in the origin, the zeros in for x and y, and see if they make true statements. So if I say 0 is greater than or equal to, again, we're putting 0 in for x, so this will 0 out. Is 0 greater than or equal to 15? No, it's not. So we can't shade towards this is not going to work because the 0, 0 inputs do not make a true expression here. Okay, so this one gets eliminated. But we want to make sure that we're doing this right. So we don't want to just go off of one piece of information. We really want to verify it. So we're going to go back to our equation up here of inequality of y is less than or equal to 20 minus x. And we're going to put this origin in here. And so do we get 0 is less than or equal to 20 minus 0, or 0 is less than or equal to 20? That is a true statement. So here we can shade this one towards the origin. So just to verify, this one gets shaded away from the origin because it's not a true statement. This one gets shaded towards the origin because it is a true statement. Therefore, anything in between here would be part of your solution set. Okay? Now, using that discovery, we're going to go on to part B. Which XY pairs represent hours that Leah could work to meet the given conditions? So we're looking at the X column being the babysitting and the Y column being the ice cream shop. So looking at the D graph, if X is 4, which would be right about there, can Y equals 15? That fall into the realm of possibility? Yes, that is part of the solution set. How about 5, 12? Does that fit into our yellow frame? 5 and up here at 12? Yes, that is also a part of the solution set. How about 10 and 9? Yep, that just fits in there nicely. How about 15 and 5? Nope, that is not part of our shaded area. And lastly, 19 and 1, also not part of our shaded area. So these did not work. If Leah babysits for 7 hours this month, what is the minimum hours she would need to work at the ice cream shop to earn at least $120? We can solve this really quickly by looking over here at the graph. Because if she's babysitting, here are our hours babysat. If she's babysitting at 7, we're going to go right here, between here. What would be the minimum number of hours? So you can take a look, and I've made a mess of this graph, but basically right about at 11, and you can plop that in for your X values to see how that comes out. But that should come out to be about 11 reading that graph. And then Leah prefers babysitting over working at the ice cream shop. Out of 20 total hours, what is the maximum number of hours she can babysit to still be able to earn $120 per month? So if you follow this all the way down here, where does this kind of stop? So if you take a look, they're going by 2.5s. So you got 2.5, 5, 7.5, 10. And if you notice, they say your answer to the nearest whole hour. So this would be 12.5, which is where it stops. So that makes it 13.